Okay, so in this video, we're going to briefly review greatest common factor and grouping, and then take a look at difference of squares, and then just practice all three. So at different points in the video, I'm just going to ask you to pause and write the questions down on your own paper and try them out, and then you'll be able to check the answers in the video as you proceed. But at those times, do pause the video and try these out. Again, using your own paper to keep track of all these notes. For your e-learning assignments, you should keep these all in one spot, in one set of notebook paper. Labeling them with the different assignment numbers would be helpful for you to refer back to. So here we go. Take a moment, pause the video, and go ahead and try to factor these first couple here. Okay, so at this point, if you factored 1, 2, and 3, factoring by GCF and by grouping, just remember when you're factoring GCF, for the variable piece, you want to circle the smallest exponent, so that would be the 2 for the x and the 3 for the y, right? So again, starting with your GCF, and then what's left over in the parenthesis should again have as many terms as you started with originally. For grouping, that's the one that was a little bit newer. So remember with grouping, remember our steps. We want to check all 4 terms together at once before we group, but once we identify that there's no GCF for all 4 terms, remember that's when we split it, and then that's when we look at taking out the GCF from each group. So from that first group, I'm just going to create that one big bar, and I can take out a 5x squared, and from the second group I can take out a 3. So I'm kind of out of space here, but when you take out the 5x squared, you're left with a 5x minus 1, and then taking out a positive 3 leaves us with 5x minus 1. So remember the matching parenthesis is one factor, and the 2 original GCFs create the second factor. Okay. Be the same process for number 3, factoring using, again, grouping. You'd have to split it, and then just notice this time in that second group, you'd have to take out the negative, so negative 8y, because that leading term is negative in the second group. For these 4, you might remember looking at a couple example questions like this. We're going to hit on these a little bit more in this video. Factoring with difference of squares, and we'll talk a little bit more specifically about that. But just to remind you what we had tried to do, if we use the box to set up these questions, most of you are actually able to factor these and didn't even know it. So with the area model, I'm going to give myself a little bit larger box. So with the area model, we set up our box, and then the 2 terms were in these 2 spots, 5x squared and minus 36. And most of you recognize that, oh, well, what if this was 5x and 5x? And then what if this was 6 and negative 6? Well, what we need to look at is that these 2 terms right here. So if I actually go and multiply that out, I get 30x and minus 30x. And those 2 terms cross off, which is why there's no middle term, right? There's no x term. So when I factor this, my answer is the sides of the box, the sides of the rectangle, right? So my 2 factors would be 5x plus 6 and 5x minus 6. That would be factored using or noticing the difference of squares. So for number 5, again, I'll use the rectangle again. If I set up the rectangle, thinking about where that first term comes from, it comes from that first box, and then the negative 81. So once again, if you think about, okay, so starting here, I know this has to be a 10 and a 10, and then an a to the third, and a to the third. And then for these other 2 sides here, a negative 9 and a positive 9. And then again, if we check, these are the 2 terms that apparently add up to nothing. So if we check that, we get 90 a to the third Sorry, pen's freaking out here. And then we get negative 90a to the third. And so those two terms, those add up to 0, which again, we notice there's no quote-unquote middle term. Okay, so my final answer then for this would be listing the two sides, writing the two sides as factors. So 10a to the third minus 9, or you could do the plus 9 first, whatever. I usually do the plus first, and 10a to the third minus 9. Now, if you start to notice patterns, which we're going to identify here shortly, for this last one here, my final answer is actually just x plus 7 and x minus 7. And we'll take a look at how we can kind of a little bit more quicker jump to that. This box, the rectangle, remember the area model is a good connection to make from the last unit to what we've done before, but that's what we're going to focus on a little bit here. So there are your answers again, maybe a little bit cleaner, easier to read. So again, these are the types of questions we're going to work on, that we want to work on, is factoring these types of polynomials. And what you'll notice is on each of these there's only two terms. Right? Each of these only has two terms, and when we factor, that means we're trying to break it down into two factors or more sometimes that multiply. If you would multiply these back together, would get you what you originally started with. So for this first one, it would just be x plus 6, x minus 6. And again, if I were to check this and start distributing, so x times x is x squared. X times negative 6 is negative 6x. 6 times x is 6x. And 6 times negative 6 is negative 36. So once again, if I think about what combines together, these two terms would combine together and cancel out, and I'd be left with the x squared and the minus 36. So in order for that to happen, in order for that middle term, the x term to cancel out, we have to have the same value, just one opposite, one negative. So that's, sorry, one positive, one negative. So that's the reason that we see one of the factors has a plus, one of them has a minus, but then you'll notice everything else about those two factors is exactly the same. X and x, 6 and 6, just one positive, one negative. So you can try the rest of these out here a moment. You can pause the video and try those, but I'm going to go ahead and move on here, and you'll have an opportunity to practice a bit here before we. So difference of squares. Here's again, take a moment when you need to, pause the video to write down everything you need to. So difference of squares, it's the pattern that we're noticing. Difference, right? Difference meaning subtraction, and squares meaning numbers or variables that are perfect squares. So you might need some reminders about those. Perfect square numbers are numbers like this, 1, 4, 9, 16, and so on. So those are perfect square numbers because 1 squared is 1, 2 squared is 4, 3 squared is 9. Each of the perfect square numbers can be created by taking another number times itself to get that number. With variables, any exponent that is even has to be even. Even exponents are perfect squares because you can divide even exponents in half, and that's what you have to do when you take a square root. Here's what really we can do to simplify a difference of squares type question is when we factor it, we can really think of it as taking the square root of both terms. So here's what that looks like. The square root of x squared is just x and x. Square root of 4 is 2 and 2. And once again, the pattern we're noticing is that one is always positive, one is always negative. So if you were to multiply that back together, you end up with just the x squared minus 4. So that's how I'm going to generally start looking at these. If I notice, again, here's two completed examples. If you think of it as the square root of 9j squared, that's 3j and 3j. A square root of 1 is just 1 and 1. Square root of a to the fourth, remember the exponent is even, so divide it by 2. You have an a squared and a squared, and then square root of b squared is just a b and a b. So again, you can go ahead and pause the video and try these, and you'll see the answers show up here in just a moment. I know it says just watch, but you can go ahead and pause it and try them, see how you're doing so far. All right, so let's do this the speedy way, right? So again, we said if I notice that I have a difference of two perfect squares, then the pattern is going to be one's positive, one's negative, and we take the square root of the first term, that's x, and the square root of the second term, that's 3 and 3. Again, the second one, it's a difference, subtraction. These are both perfect squares. So 2x plus 6, 2x minus 6. Again, think of it as a square root. So last one, square root of those two things, 9x plus 7, 9x minus 7. Okay, here's a few more. This time, do pause the video and see if you got the idea down. Try it out and then unpause and check your work. Okay, go ahead and check those. Some of the trickier ones often are the ones where you see a -1 here. 1 is a perfect square, so the square root of 1 is just 1, 1 and 1. Okay, so that's a common mistake there. And then just be careful, right? Squared, right, or even exponents, right? Dividing by 2, right? Think of it as dividing by 2, and that's why you just have an h and h and a g and a g for these. So on this slide, go ahead and now pause the video, try them all, and then again you can check your work here. Really, it's just a matter of identifying the two things, right? So, well, kind of three things. So you're looking for a difference, right? So notice difference, difference, difference of squares. So they have to be two perfect squares for the pattern to work. And then the other thing you're looking for is it's just two terms. Right, so all of these have only two terms, so that's the first thing to check, but all of these are good to go. It's the difference of squares that you need to check. So go ahead and work through those, try them out. Again, these would be great examples to have in your notes on your notebook paper that you're keeping. So try them out, pause the video, check them. All right, so pause the video and check them and see how you did. And then after this, we'll go through just a couple more little details to watch out for. And then you'll have a chance to try out just GCF grouping and difference of squares factoring. And in the next lesson, you'll get into the last type of factoring that we'll work on. All right, so number 9 was the difference. And if you noticed on, you noticed that it was r squared plus, right? So r squared plus 25 was number 9. And if you think, oh, well, it's just the same thing, r plus 5, r minus 5. Well, if we multiply that out, right, if we distribute that, right, if you remember, you could also use the area model to do your r plus 5, r minus 5. Well, then we're going to get an r squared, we're going to get a negative 5r, we're going to get a 5r, and we're going to get a negative 25. And these two terms are going to cancel out, and I'm going to be left with r squared minus 25. But that is not quite what we started with. We started with r squared plus 25. So here's the thing. First of all, that's not the same thing, but this is not a difference. Right? This is not a difference. It's adding. It's adding r squared and 25. So the pattern does not work. So that's where in mathematics with patterns you have to make sure you know when do they work and a lot of the time it's helpful to know why they work, which is where the area model connection can really help you figure that out. Okay. So at this point, again, just to review quick, looking at a couple difference of squares questions. Two things you're looking for: difference of two perfect squares. Again, even exponents are what you're looking for when we're looking at the exponent piece. So can you do the difference of squares to this, right? So is it a difference, and are these two things perfect squares? Again, the difference is easy to check, yes. And these are two perfect squares, right? It's an even exponent, and 9 is a perfect square number. Yes, you can. It is x minus 3 and x plus 3. For this one, can you do difference of squares, right? Again, you're looking for, is it a difference? Right away, nope. So no, you cannot do difference of squares. We call that prime, and I forgot to mention that earlier. But if there's nothing you can do to factor something, it's just prime. In this case, it's prime because it's not subtraction, it's not a difference. It'd be like the same thing as saying, well, take the number 13 and try to make a prime factor tree. Well, the only thing that you can do to do a prime factor tree is do 1 and the number 13. So that doesn't really help us break down the number 13 any farther than it is. So 13 itself is prime. So just like 13, well, x squared plus 36 is prime. It's a prime polynomial. Here's another one, x squared minus 20. So again, going through your checklist, is it a difference? Yes. Is it a difference of two squares? X squared, yes. Even exponent. But 20, no. Not a perfect square. Right? So 20 is not a perfect square, so you cannot use, even though it's a difference, and it's only two terms, 20 is not a perfect. One or two more for you. Again, is it a difference? Yes. Are these both perfect squares? So factors to 2x minus 5, 2x plus 5. Last one here. In this case, again, difference, yes. Of squares, so 16, yes, is a perfect square. X squared, yes. 8, no. 8 is not a perfect square, okay? Now, one thing you might notice, though, it's not a difference of squares, but this one is not prime. You can actually do something to factor this. So we know it's not a difference of two squares, so that pattern we're trying to use doesn't work. But what I do notice is you can take an 8 out of both of those things. So that would be not a difference of squares, GCF. So you can take out GCF of 8, and then what you're left with is 2x squared minus 1. So it's not prime, but it's just also, it's not a difference of squares. Okay, so in this PowerPoint, or in this video, you can now pause the video at these various times to write down and complete these questions. And then at the end of this video, you'll have the answers. There's also documents posted on Canvas that have these in there as well if you don't want to sit here and pause and play the video. So check those out if you want. But otherwise, work on completing these, and this would be, at this point, this is 3 out of the 4 types of factoring that we work on. Difference of squares, grouping, and GCF. So you only have one more type of factoring to practice and get good at, but it is one that's usually maybe a little bit tougher than each of these. And there are your answers. Again, check those carefully. Make sure you're doing okay with each of these. And again, feel free to shoot me any questions in an email or through Canvas. But just make sure you're working at this and trying to get better as best you can. Okay.